Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are going to continue our discussion on system implementation. So, previously we talked about the importance of design, prototype, evaluate cycle. We learned about different prototyping approaches. Just to recollect, we have two categories of prototype, vertical and horizontal. We have 4 approaches to build prototypes: low fidelity, medium fidelity and high fidelity, as well as Wizard of Oz. And we have 3 ways to use the prototypes, that is thrown away, incremental and evolutionary usage. Also we talked about the expert evaluation techniques. We talked about 2 such techniques, cognitive walkthrough and heuristic evaluation, which are used to quickly evaluate the prototypes. We are going to continue our discussion on another quick evaluation technique, our discussion on evaluation techniques, and we are going to cover another quick evaluation techniques, that is the user evaluation. Along with that, we are also going to briefly talk about how we implemented the Majuli tour. So, let us talk about the third quick evaluation technique, that is user evaluation. Now, basic idea here is to, as we have already noted earlier, to get quick feedback from users by asking them questions directly. So, in this case user evaluation, we have to involve the users. In the previous 2 expert evaluation techniques, involvement of users was optional. But in case of user evaluation, it is mandatory. Now, this is often called evaluation with self reports. The user feedback is collected with some rating scales, and the data collected sometimes are called subjective or preference data. Collection of feedback with the rating scales is easy as compared to more rigorous evaluation techniques. However, there are 2 major points of concern. The first issue is that when we collect user feedback on a rating scale, we collect ratings on items. Now, these items are essentially questions or statements. For example, rate the statement, the controls are easily accessible on a 3-point Likert scale. Now, the Likert scale is of course a well known rating scale, and these type of questions or statements will be provided to the users for them to rate on such a scale. Now, the prerequisite is we have to identify suitable items or questionnaire. So, these items are commonly referred to as questionnaire, although it need not contain questions, they can be statements as well. Now, it is of course quite challenging to identify suitable questionnaire, that is the first issue. The second issue is we have 2 points for data collection after every task. So, we are assuming that the users are given some tasks to perform on the prototype, and then we are collecting feedback. Now, there can be 2 data collection points. One is after every task is performed, and second thing is at the end of the session where all the tasks are performed. So, when should we collect the data? Of course, it is desirable to collect data at both the points if feasible. Otherwise, we have to choose either of these 2 points. Now, depending on when we are collecting the data, we have to create suitable questionnaire. So, corresponding questionnaires may not be the same. So, questionnaire required to collect data after every task need not be the same as the questionnaire required to collect data after the whole session. So, depending on these different requirements, we can have different questionnaires. Already there are well known questionnaires available which can be directly used. So, for post task data collection, we have post-task questionnaires such as after scenario questionnaire or ASQ, designed way back in 1991 by Lewis. Then expectation measure or EM questionnaire, designed in 2003 by Albert and Dixon. Similarly, for post-session data collection, we have post-session questionnaires such as System Usability Scale or SUS, a very popular questionnaire designed in 1996 by Brook. Then Computer System Usability Questionnaire CSUQ, again designed by Lewis in 1995. Questionnaire for User Interface Satisfaction QUIS, designed by Chin et al. In 1988, that is even before. Then Usefulness, Satisfaction and Ease of Use Questionnaire or USE, proposed by Lund in 2001. So, as you can see, there are different questionnaire sets meant for collecting data at different points of time. So, let us quickly go through an example from each of these two types of questionnaires to get some idea on the nature of the questionnaires. So, let us talk about post task questionnaire. We have seen two, out of which let us talk about the ASQ, after scenario questionnaire. So, it is a post task questionnaire, consists of 3 statements, although we are calling it questionnaire, but essentially there are 3 statements in that questionnaire. Users are asked to provide rating on a 7-point rating scale for each statement in the questionnaire. What are those statements? We will see soon. Now, ratings range from strongly disagree with the statement, that is rating 1, to strongly agree, that is rating 7. So, let us see the statements in the questionnaire. First one is, I am satisfied with the ease of completing the tasks in this scenario. The user has to rate between 1 to 7. 2 is, I am satisfied with the amount of time it took to complete the tasks in this scenario. Again, between 1 to 7, the user has to rate the satisfaction level. Third is, I am satisfied with the support information, that is comprising of online help, message, documentation when completing the tasks. User has to rate this statement in a scale of 1 to 7. So, these 3 are the statements that comprises of the ASQ questionnaire. Now, the first statement is related to the effectiveness measure of usability. Efficiency aspect is covered in the second statement, and all the 3 taken together represents satisfaction. We can roughly map the 3 measures of usability as mentioned in the ISO definition to these 3 statements. How we are going to use the feedback? We can consider average rating for each statement collected from all the users who participated in the evaluation, or average rating for all statements taken together. So, either we can average out for each statement, or for all statements taken together we can take an average value. So, either way is possible. Now, let us talk about another questionnaire, that is SUS, System Usability Scale. So, this is a post session questionnaire. Earlier we talked about post task questionnaire, now this is post session questionnaire. That means it is administered, or the feedback is collected at the end of the session when users completed all the tasks. Now, it consists of 10 statements. Again, we are calling it questionnaire, but it contains statements rather than questions. Out of these 10, half or 5 statements are positively worded. These are statement numbers 1, 3, 5, 7 and 9. Assuming that we have numbered the statements from 1 to 10. So, every alternative statement starting from the first one is a positively worded statement, and the other half is negatively worded, that is 2, 4, 6, 8 and 10. Let us have a look at the statements. Now, question number 1 or statement number 1 you can see is that I think that I would like to use this system frequently. So, this is a positively worded statement. 2 is I found the system unnecessarily complex. This is a negatively worded statement. Statement number 3 is I thought the system was easy to use, again positively worded. 4 is I think I would need the support of a technical person to be able to use the system, negatively worded. So, as you can see, first and second statements are related, one is positively worded, other one is the negatively worded version of the same statement. Similarly, 3 and 4 are related, 5 and 6 are also related. 5 is I found the various functions in this system were well integrated, whereas 6 says I thought the system was too inconsistent. So, 6 is the negative version of 5. Similarly, 8 is the negative version of 7. 7 states that I would imagine that most people would learn to use the system very quickly, whereas 8 says that I found the system very cumbersome to use. Finally, 10 is the negative version of 9. 9 says I felt very confident using the system, whereas 10 says I needed to learn a lot of things before I could get going with this system. Now, each of these statements a user is supposed to rate on a scale of 1 to 5, that is a 5-point agreement scale, where 1 indicates strongly disagree and 5 indicates strongly agree. In the ASQ questionnaire, rating scale was 1 to 7, here it is 1 to 5. Now, how to use the rating? Earlier we saw that we can use the rating for ASQ, that is post task questionnaire, by just taking out average either question wise or all the 3 statements taken together. Here it is a little bit different. Here what we can do is that we can combine the ratings for all 10 statements to obtain an overall SUS score using the formula S, that is the score, equal to summation of Ri minus 1 plus summation of 5 minus Ri. This whole thing is multiplied by 2.5, where Ri is the rating for the ith statement. I ranges from 1 to 10. So, when the I is taking the values of the positive statements, that is 1, 3, 5, 7, 9, the expression is Ri minus 1. So, rating minus 1, and when it is the negative statements, that is 2, 4, 6, 8, 9, then we use the expression 5 minus Ri. Then we add these two weighted sums, add these two sums and then multiply it with 2.5. That is the formulation to combine the scores. We can interpret the score as percentage. So, whatever result we get after doing this calculation, we can convert it to percentage directly. Typically, SUS score around 70% or higher, that score is desirable. So, we can assume that if the score is 70% or higher, then the interface is usable. If it is below 70%, scores lower than that 70% might indicate usability problems. So, we may need to have a relook at the design. So, unlike the expert evaluation technique, as you can see here, the scores do not give detailed report because it is coming from the users. Users themselves may not know the reason for the satisfaction or dissatisfaction. So, in that case, the designers have to further brainstorm and identify the problem. It will only tell that there is a problem or not. If the SUS score is greater than 70% or equal to 70%, then there is likely to be no problem or very minimal problem not to be bothered about. If it is less than 70%, then there are problems, but these problems the designers have to find out through further brainstorming, maybe by looking at the scores of the different statements and then inferring from there where exactly the problem is. So, the previous evaluation techniques probably or most likely are better for the designers. It gives more detailed report from each evaluator, so that it is easier for the designer to identify the problems. In this case, it is not so easy. it can identify the problem quickly by taking user feedback in the form of ratings, but pinpointing the problem requires more effort from the designers. Now, ASQ, SUS, these are or questionnaires that are meant for interactive systems, not specifically meant for extended reality systems. So, they are generic questionnaires applicable to any interactive systems. Now, there are few questionnaires which are more commonly used in and specifically designed for XR. Some of these questionnaires we have already discussed in module 1, where in the lecture number 11, we talked about questionnaires specifically meant for cyber sickness. Let us quickly recap those. So, we have simulator sickness questionnaire or SSQ, this is most extensively used. Other relevant questionnaires are virtual reality sickness questionnaire VRSQ, cyber sickness questionnaire CSQ. It is good for evaluating VR experience with HMDs. Shorter and more precise, more concise questionnaires are there to assess specific conditions such as misery scale or MIS, fast motion sickness scale or FMS. We can also measure susceptibility to CS using motion history questionnaire MHQ, motion sickness susceptibility questionnaire MSSQ, visually induced motion sickness susceptibility questionnaire VIMS-SQ. Also commonly used questionnaires to assess overall discomfort are also there, such as nausea scale, motion sickness assessment questionnaire or MSAQ and so on. So, these are specifically designed for immersive experiences. To be more precise, these are specifically designed for specific aspects of immersive experience, that is primarily related to cyber sickness. Now, let us quickly move our focus to how we implemented this implementation ideas in our case, that is Majuli VR Tour. So, whatever we have learned so far, namely design considerations, prototype building and expert evaluations, are meant to fine tune the design. The next stage is full scale system implementation, and that implementation we are going to briefly talk about here in the case of Majuli. So, the tour was developed using the Unity engine, the XR engine Unity version 2021.3.22 F1. It was developed for Oculus Quest 2 platform and also Android smartphones, where we used older version of Android version 6. We employed the XR toolkit for the Quest version and the Google VR SDK for the cardboard version. Also, we utilized Autodesk Maya software to create 3D models for the immersive experience, where we used the real images as references and utilized the real image as texture on modeled objects. Now, there are some concerns. One concern was optimizing the size. So, initial application size, because the content was heavy to cover the entire geographic spread, the application size was 9.85 GB. Now, to reduce the space requirements, we used cloud to store all the videos, cloud services. When a user clicks on the video thumbnail from the video player in the Quest, that is the video player that is seen on that tablet interface, then the video is loaded from cloud and played. So, it is not that the video is always there in the client device. So, it led to the reduced application size of 5.1 GB. Now, we also created a mobile version to be experienced with Google Cardboard. This 5.1 GB size application was not suitable for deployment on mobiles. So, what we used is compressed images. So, whatever images 360-degree or 2D images we have captured in high resolution, we compress those to reduce the storage requirements. Also, we reduce the video playback support for many of the cases except one or two video playback support. We removed most of the video playback support for making it deployable on mobile devices. So, with those optimization processing done, the size got reduced to 0.7 GB, which we deployed on mobiles to be experienced with a Google Cardboard device. Just let us have a quick look at the different optimizations we achieved. So, in Oculus Quest version the size was 5.1 GB, whereas for mobile or cardboard version it was 0.7 GB. Number of images in Oculus Quest, all the images 597. We also used all the images, but in a compressed form in the cardboard version. Number of cultural videos, it was 11 there, but no such videos were used in cardboard or mobile version. Number of drone videos, 8 videos were used in the Quest version, whereas no videos were used in the mobile version. 360-degree videos, there were 5 used in the Quest version and 1 used in the cardboard version for the initial experience. Development platform used Unity in both the cases. SDKs used XR toolkit for the Oculus Quest and Google VR for the cardboard version, and the OS requirement was Android 6.0 in both the cases. So, let us quickly go through the implementation in the form of demos. Okay. So, let us have a look at the implementation of the Majuli VR tours. So, we have made 3 implementations. Accordingly, let us have a look at each of these 3. So, first one is a tour using 360-degree images, and it was made for the Oculus Quest platform, as we said. Let us quickly have a look in a brief video on the implementation. So, as you can see, this is the start screen, and then there is this ray casting based selection method, and in the start screen initial video and other things are to be played, video on Majuli and also tutorial, and then user can make selections on the start screen. It shows about Majuli, and also it talks about how to control the system, how to use the system. So, different aspects of the Majuli island is shown. Then there is this user group selection, and that is followed by boat ride experience, that is traversing the river through a boat from the mainland to the island. It is actually a 360-degree video captured during our field trips, and that is used here to give the user experience of traveling through a boat. Then the user reaches the river bank, and there this tablet interface appears. User can select location using the tablet interface, the map, and then can go to a particular location. There, once the user enters a location, then this place appears, where this using the arrow keys user can move forward, backward, and also you can see the icons meant for information. Plus, at a place there is notification if there are some cultural videos to be experienced, and that gets played on the tablet interface, as we have discussed before. So, user can move from one point to another using the overall island map on the tablet interface, and this is the mini map or the world in miniature support as we have discussed. So, in a location where the user is depicted on a minimap of the location, where you can see on this minimap interface there are white dots. Each white dot represents a 360-degree image. So, when user moves, that means moving from one image to another, and the user's current location is marked in green. And you can hear the so there is this ambient sound also added. And to travel from one point to another along with teleportation, we have used this vehicle metaphor, which is kind of route planning. Route is fixed, but user can experience the movement along the road as if the user is sitting on a vehicle and moving along the road. Once reaching a destination, user can move forward by following the arrow keys as shown here. And each selection of arrow key actually transports the user from one image to the next image, and during transitions we have used techniques as discussed earlier to enhance the quality of experience. So, at different points, different cultural videos are to be experienced, and also different activities can be experienced. This is the implementation for Oculus Quest using 360-degree images and the cultural videos as well as 360-degree videos. Our next implementation is the tour using a 3D model. So, earlier we used 360-degree images and videos to create the experience. Here we used 3D models to create the experience. So, as you can see here, the model of the entrance to a satra is created and used for the experience, unlike the previous case where we used the actual 360-degree images. So, this is for Kamalabadi Satra, a prominent spot on the Majuli island. Then the entire campus was modeled, and then you can move along the roads to enter different parts of the campus. Then we have created model for the villages, the dwelling units. So, this is 3D model based. And to create the models, of course, we have used the texture from the real images and then used those to create a realistic looking model. Now, this model based implementation was also meant for headsets, Oculus Quest headset. The third implementation is for mobile devices. So, this was one done to experience with a Google Cardboard, where you can insert your phone and you can have a 360-degree experience. So, the deployment would be on your smartphone, and then the smartphone can be inserted into the Google Cardboard device, and then you can experience it. So, this is the kind of experience. Here we have not used the videos, most of the videos, to optimize the size as mentioned earlier, and simpler controls were provided, and less number of features were provided. So, this is the boat ride experience which we kept. In the same tablet interface, but in a different form, and also mini map is there, as you can see. at each place. However, in most of the places we have not used the culture videos to save on space. Some prominent videos were used, but not all. So, this obviously gives a more reduced form of experience as compared to the full fledged version implemented for the headsets such as Oculus Quest. But other modes of navigation and selection and manipulation were more or less the same. We have arrows and so on. Okay, let us summarize the discussion that we have done so far. So, we talked about the design, prototype, evaluate life cycle, how to build and evaluate prototypes. Also, we talked about the expert evaluation techniques and how we implemented the Majuli VR tour. So, with that we have come to the end to the discussion on implementation part. The next part that is remaining on this implementation concept, implementation topic is how to evaluate for usability through full fledged user evaluation. So, previously we talked about quick and cheap evaluation using expert evaluation techniques or some quick user evaluation techniques. Next we are going to talk about empirical evaluation in details. So, I hope you could follow the topics and able to understand the concepts. So, looking forward to meet you in the next part of the lecture. Till then, thank you, goodbye and happy learning.